Welcome back to Machinist Made. Today we're going to go over some basic functionalities in the manufacturing tab of Fusion 360. This is going to be a multi-part series. This is just one of several videos of this series to teach you pretty much everything you need to know for general 3-axis and even 4th-axis machining inside of Fusion 360. So today we're going to go over the setup process. We're going to explain all of the different tabs within setup. So to get started, our setup tab is up here just under milling. We click on setup. You have several different options under here. Matter of fact, you've got 4. You've got orientation, you've got origin, and you've got stock point. So under my orientation, the way I always set up a part is I select Z-axis. You'll see more options open up. And I will tell in Fusion what my Z-axis plane is. Now this only sets the direction of your Z-axis to up and down. So if I go to the bottom of my part and I tell it I want that to be my Z-axis, you see how it flipped across the center line. Now let's say, for instance, I want my X-axis to be going from front to back instead of my Y. To do that, I would go to my X-axis and I would select this plane and have my X-axis point to this surface. Now I understand a lot of people don't actually need this function a lot of times. You know, normally we just turn up or turn down our Z and we go from there. So I'm actually not going to do that today. I'm going to leave this X-axis blank because I don't need it. The next thing I'm going to talk about is the flip axis. You know, it's just a toggle up and down. Now, under origin, we've got a couple different options under origin: model origin, selected point, model box point, and stock point. I like to use stock points because it's easier from a machinist's reference to know that you're coming off the top of your material. Now if this was a finished part, let's say this is like an OP3 or OP4 where it came off another machine or it came back from external processing of your facility. Let's say you need to engrave some part numbers on a ground surface, but you don't want it to be engraved before the grinding process. You want to engrave it afterwards to ensure you're hitting your engraved depth. This is something that I have done quite a lot out in industry. You would want to go to model origin. See how it actually highlights my model? Now my origin is directly on top of my part. This makes it very easy again for finished parts to be able to pick up on a known origin. Selected point is you want to select a point. Let's say I want to select the center point of that circle. A lot of tool and die makers and mold makers will want to pick up on a dowel hole. So I can select a feature and boom, I have now moved my origin somewhere else within the part. Model box points are kind of like stock box points, but model related only. You'll notice these points are only related to the model. So let's say our model origin is here from the print. The one I like to use is box point, and my box point is related to my material. See how my material is a lot bigger than my part, which most machine parts are. I can select that material because, again, machinists know the size of their material because it's usually in their hand. And if you're the programmer, you're usually in charge of ordering the material or speccing the material for a purchasing agent to order. The next thing with this in this tab is models. Now obviously our model is our body. If you had an assembly of 3 or 4 parts together and you wanted to make sure that within this assembly you were on the correct part, you could again do this. And the same thing for fixture. If you was going to use a fixture, you could come in here and select your fixture attachment points, and this will actually avoid your fixture inside the machining process. It'll leave those areas as collision avoidance. Obviously this part doesn't have a fixture, so we're not going to be using that function today. Now up here at the top, this is only one of 3 tabs. So inside the second tab are my stock points. We talk about material sizes. So within stock, depending on again what you're doing, but for the most part, it's going to be one of 3 selections. It's going to be a fixed size box, it's going to be a fixed size cylinder, or a fixed size tube. The last one I've used a lot, but only in very specialized circumstances, which is from solid. If you're dealing with castings, you can model your casting inside of Fusion and use that casted model and able to actually do, again, collision avoidance and to speed up your machine processes. And a quick note, while we don't use relative, when we order material, we know what size material we're going to order. So that's why we don't typically see relative anything. So I'll use fixed size box 90% of the time, and then I'm able to tell, and you can have Fusion do this as well, where it will actually spec the material for you, and you can tell it to round to the nearest whatever, half inch, quarter inch, eighth inch, depending on your size of material will depend on whether or not you need to round to whatever position. Material usually comes in eighth, quarter, and half inch increments. So that's how you would order your material. If you're in metrics typically go millimeter, millimeter and a half. But again, for today, it's saying I need a 4 by 2 by 1 inch part. And my preferences within my profile is set to the nearest half inch. That gets me as close as I need to be, and honestly and truly, it's close enough for what I do. I could go down a size. It's actually going to tell you your model dimension right here. And honestly and truly, that's just not enough. You can get away with holding on to that little bit of material, but you run a very high risk of pulling the material out of the jaws or out of the vise or out of a chuck or out of whatever work holding that you're using. You want to be holding on to at least, and I say at least, 10% of the thickness of the part. So in this case, this being a 700 thousandths part, I'd want to hold on to at least 70 thousandths. My closest reference to that would be 100 thousandths, but in this case, they don't make 800 thousandths material. So we're going to go to 1 inch, which is the next nominal size. To move these around, you see this part is dead smack in the middle. That's not particularly what I want. I want as much material on the bottom of this part, what we call the hat, to hold on to. So I'm going to make a small adjustment. We're going to go model position, and this works for all of them. Offset from top, and we're going to change that offset to 20 thousandths. This gives me a lot of material to work with on the bottom of the part. It gives me better holding power. It gives me better rigidity. It allows the shock or the machining vibrations to go down into the vise more evenly. The next tab we're going to look at is post-processing. This comes down to your machine. Program name and numbers that you have to use. I work on FANUC or FANUC based controls, so I'm going to use a program number that it's going to recognize, which is 4 digits. You can use 5-digit numbers on FANUC controls, and my program comment, I always name my program in the comment what I'm doing. This will be PNV file, and that stands for Program and Verify File, Challenge V1. And my machine offset is going to be offset 1. Well, on Fusion, since this is, I'm going to end up pulling a post-processing file for a Haas control or a FANUC control, then 1 will mean G54 in my post. Now back to the first tab, we're going to talk about machine. This concludes it for how to use the setup tab inside of Fusion. This is a little more in depth than what I usually go through when I'm doing my general programming. The next one will be on the first machining op, which is facing, and then we will kind of progress from there. Hope you liked this video. Make sure you like and subscribe, and hopefully I'll see you back here.